Hi everyone. First of all, just a small disclaimer. I kind of renamed the presentation to how to ensure sanity because testing seemed quite misleading sometimes. People thought that we were really like re-implementing PyTest, which is totally not true. That's it. So first of all, just to introduce myself, my name is Alex Viscreanu. I've been working as a full stack developer for 3 years now. Right now I'm working in the platform team at Kiwi, which is meant to do internal development for other devs. So we try to make them develop better software faster. That's our main goal. And you can find me as Axvira almost everywhere. Just to build some context, I will give some information about the scale that KiwiCom has, because that makes a lot of sense when I will explain why we did this. We are an online tradable agency, which is totally different from a search engine. Of course, you can search flights on KiwiCom, but the main point is not that we will redirect you on the page. We are an online travel agency, so we sell the tickets. That allows us to do cool stuff like virtual interlighting, where we combine flights from 2 different carriers that usually don't cooperate. Or our main last feature, Nomad, which allows you to specify a bunch of cities and we will find the most optimal route for that. Right now we are averaging to 90 million daily searches. We have over 15,000 million flight combinations, and we sell around 25,000 seats per day, which is different than tickets. This means that we really need highly available systems. We cannot we cannot lose some performance anywhere, or we cannot allow to have some small issue getting to production. Our infrastructure is composed by 300 microservices. They range from just simple ticketing solutions to stuff for making invoices, for integration with carriers, everything. And we have in our GitLab around 1,500 projects, and 75% of them are Python. We have our core search engine built in C++ because of performance reasons. Every other backend, it's usually Python. Just right now, we are starting to play with Golang. And the most important fact is that the most important services are usually the oldest one, because they were the first one built and legacy code everywhere. It's easy to make a new service from the ground up, updated with new technologies, but it's not that easy to know how older services, like 4-year-old services, are performing. So that's kind of our need, and that's why we started this project, because we need an automated way to check code at scale. I'm not talking about SonarQube or like static analysis of code. That's something totally different, and we still use those tools. This is only meant for making our own decisions. We want to make sure that we don't have any single repository in all our projects that have some stuff that we found out that it's not good. So that's why we built the zoo. That Russian phrase is from Gregory, who recommended it because it seems that it explains why this project. I don't know how to pronounce it, so I'm not even going to try. So what is the zoo? It started as a microservice catalog because when you have 300 microservices, it's hard to locate them, and we had issues all the time with people trying to figure out which service is the one responding to some endpoint, for example. But on top of that, we built a repository analysis platform, and it's a platform just because we thought that it's going to be much more beneficial having this in a modular way, so everybody can contribute to it, than having to build ourselves everything every time. We need to keep track of this, so we cannot really afford using like just the virtual control system. We have a bunch of repositories there, but like we have infrastructure repositories, we have libraries. Those are not services, so we don't really need to index those. And also, we could just use Excel, for example, as a microservice catalog. That would work. It's a list, you can search on it, but it wouldn't allow us to build the static analysis code. So this is the main feature on the zoo. This is what makes it useful for us, really. We audit every single repository we have, like those 1,500 repositories, we audit them every hour. It's a scheduled task, it runs over every repository. It gathers results and generates a report for every one of them. The issues we scan range from just like best practices that we found out or during the years to some more advanced security flaws that we found. And just as a nice small story, we built this before GitLab, which is our virtual control system, has, like, they build their own SAST image for checking security stuff. And in fact, they are kind of using the same technology we are using, which is relying on some third-party library, which is Bandit in this case for Python. Yeah. So after we built the auditing module for detecting all those issues, we also realized that many of them were just like one-line change on code. But then when you have a team with 40 people that are pushed to deliver features because that's more important than fixing code, well, you have them stale for months. So we built a code patching and merge request mechanism. So once we write what we want to check in the code in the repository, we also can write a function that patches the code and automatically submit a merge request to GitLab, and they just have to review it and accept it. This approach is quite basic in the way that right now, for example, we are mostly doing text replacement, but it's quite powerful because it's not limited to that. You only get a file system root with files, and you can do whatever you want with them. So if you want to build a IS tree and parse it and try to, I don't know, change more advanced stuff, it's also doable. And after that, we thought that, yeah, caring about old projects is important because, as I said, most of our most important services are quite old. But also we have new projects done without like any guidance from anyone. So we end up with a messy situation where people is implementing logging in different ways. People it's reporting metrics to different places. So we just built a dynamic production checklist, which is like just a list of things that everyone should go through before launching service to production. That's dynamic because we have like checklist items specifically for Python, checklist items specifically for API applications, checklist for applications that deal with customer data because that's more sensitive and it has to be treated in a different way. And we also have third-party integrations. The main important one is Sentry right now. We use Sentry for collecting errors, but the problem is that sometimes there has been a bad release, and you end up with a bunch of errors that will stay there, making noise until Sentry clears them out, which is usually, I think, 1 month, unless it's configured otherwise. And also there are like buried within all other errors, some smaller ones that are more harmful for us. So our Sentry integration, it's not like the one that GitLab built, by the way, also after us, which is just like gathering the list of every error we have. Our integration scans for what's the most important issue and how many times has happened before reporting it there or not. So it's like filtering issues from Sentry. Datadog and Pingdom are also integrated. We use Datadog for gathering metrics from almost every service. So as a way to have some service level agreement service level objective and service level SLI. I don't know what is that. We integrated the zoo with Datadog and Pingdom, so we get queries from there, and we just compare it with some value that we want to achieve. So if we want to have 99.99% of availability, we can just check it here. And instead of having to go, like having someone to have to go to the zoo to check which issues their service has, we integrated with CI because we heavily rely on CI. If everything goes wrong, it's usually because CI is not properly set. If some error goes to production, it's because there is no proper check in CI. If I don't know, some import is not there, it's probably because in CI there is something not properly checked. So every time somebody makes a merge request, we send a request to the zoo scans the repo and submits back the report, the same report you have in the page, but tracking status changes. So if you fixed an error with this merge request, you will have it there. If you reopen an old issue, you will also have it there. And if it's a new issue, it's also there, of course. And of course, it's open source. Maybe it sounds like a cliche because everyone does the same, but it's just wanted to give back, kind of. We are using open source technologies for building this, and we think that it's something that more people could benefit from. And the most important part, which is, I think the core idea, is that there is smarter people that have better approaches, and at the end we will benefit from those approaches as well, because this is our product, this is something we are using, and if we can get it improved by like collective knowledge, it's awesome. So how do you use Zoo? Right now it's a pretty easy process. First step is just clone the repository from GitHub, then run the migrations, create a super user. It's a Django application, so I will explain that later, but yeah, it's standard Django application, so run migrations, create super user, and there you are, up to go. We are using Docker almost everywhere, so this is using Docker Compose. It's going to build a Docker image if you don't have it, and it will deploy it and run all the extra services that you need, like Redis or Postgre or whatever. And you will get something like this. This is not exactly true because I skipped some basic steps like setting environment variables. Of course, you need to specify which access token to this will use for connecting with GitLab. But this screenshot is from the auditing report, and there you can see like what kind of issues we are reporting and how do they look. And yeah, which technology did we use? Django is a backend framework. It's robust, it's stable, it has been working really nice. It has also features like the ORM templating engine. It's, I don't know, just works really well for us, and it's really affordable for other devs to join and develop more stuff on the zoo. We use Celery for task management. Every repository scan, every sync with a third-party service, it's everything going through Celery. Vue.js for the front end that needs logic. We try to have an approach where everything everything should be a template unless you really need to. Right now we only have two places where we have Vue.js components, but that's because we needed client-side logic. If we need client-side logic, it should be Vue.js. If not, just use a template. PostgreSQL for the database, Redis for in-memory database. Celery uses it, and we also use it for like some small features. And Webpack for building the static files. So the main important part, what about the checks? Because this is like the main thing we are doing right now with this technology. To provide the checks, you need to provide a Python package. We built it that way because we thought that people might want to provide the checks as a Python package, and you would just use the base image and just install package. So you will end up with all those checks integrated. We are using an auto-discovery approach similar to PyTest, in the way that we scan all the code inside that Python package and try to find modules and functions prefixed with check underscore. The rest of the functions are ignored, so if you need auxiliary functions or some third-party integration also for reporting it somewhere else or whatever, it's also there. Just don't name it check underscore, and that's it. And all the check functions will receive a context object, which has metadata and the file system where the Git repository is cloned. The scanning is done by just getting an archive for the code. You get a file system root with all the code there, and you are free to do whatever you think with the code. And the metadata includes stuff like which languages are present in the repository, because you would like to avoid trying to check for Python requirements files if it's not a Python project, or even if the owner is a personal namespace, which you don't really care about those projects, so why scanning personal projects that shouldn't go anywhere? I don't know. Everyone is free to do whatever logic they think. And we rely on third-party tools as much as possible. Like, the key is not to re-implement the wheel. We wanted to have security checks because there wasn't any universal way to do it. Right now, as I said, GitLab has their own static analysis security tool image, and they also have the dynamic one. We are using Bandit for Python, which is a PyCQA module. We also use Jixi from Yandex for checking for nginx configuration, like nginx misconfigurations. Those are quite easy to spot with a tool like this, and it's like worrying how many times people has misconfigured nginx servers. Trufflehog for scanning for high entropy strings, which is usually like those are secrets that shouldn't be committed to the repository. And even Joe, which is, I don't know if you know it, it's just a small tool for generating gitignore files. Not everyone uses generated gitignore, so they just add stuff as they come up with them. So sometimes some things that shouldn't be committed are there. So for every repository, we run Joe based on the languages they have, and we submit a patch with all the new gitignore file that you should be using. And this is a really small, simple example of how a check looks. This is a simplified part of one of our checks, which is for the setup.py file. In this case, we filter out not Python repositories because it doesn't make sense. Those repositories don't usually have setup.py files. Then we only try to scan if the setup.py file actually exists. And we are reporting two issues right now, which is first that some snippet has to be used. That's done from another function. Right now I'm not remembering what that function does. And the other one, which is just missing an author. Of course, this check is much larger, but it just didn't fit and didn't make sense. Like, the point is to see how simple it is to write a check there. And I will show some of our checks, which is something that we think that could be beneficial for other companies or even people that has a small amount of projects. Take it as inspiration. Right now, these checks are not open sourced yet, mostly because we need to do some cleanup, but they will be eventually, a couple months, open source as well, available on our GitHub. The first one is regarding the requirements files. We want to ensure that not everyone just commits some random requirements file without any single logic behind. So the first thing we do is having blacklisted requirements. There are old libraries for JSON processing that where they have some tendency to do segfaults when trying to parse huge objects, and we just don't want people to use them when we have better alternatives. We also want to make sure that people use our internal PyPI, because we have our internal PyPI where we publish our packages, which is also mirroring the official PyPI, and we have some logic in that middle layer. So every time, everybody should be using our own PyPI instead of the official one. Just some simple check that HTTPS is enabled, because why not? And for managing requirements, we usually rely on pip tools for now, although we are trying to find a better solution. Currently looking into poetry, because pip tools has some limitations, mostly with merging files, like when you have multiple requirements files and they have clashing requirements on both of them, you will end up with some requirement that it's not easily handleable. So that's for now. The next one is for GitLab CI, which is, as I said, our main CI pipeline system. The first thing is we check that Docker login, which is something quite basic. Many people forget about it. We check that every Docker job has Docker logging, and it's Docker logging properly formatted for our own registry, which we also have. We also check that there is a global image on the pipeline, because people used to rely on the one we include in the runner itself, which is by default just Docker. And sometimes they have stuff and they assume that it's going to work forever until we change the base image of the runners because we need to, and then 50 pipelines start failing because they were assuming that that always is going to be Docker. So we just want to have a top-level image used for the whole pipeline unless overridden by some job. We also check that the repository is shallowly cloned. This is huge, really important for big repositories. Our front-end repository is extremely old and extremely big. It's like 2 gigabytes or something like that. So trying to clone every time 2 gigabytes, it's a lot of time. And something that it's also overlooked, which is Docker layer caching. It helps speeding up the builds a lot when you just do coding, changes in code. For projects like Python projects, where you don't really, your code doesn't need to be compiled, it's extremely fast to just cache the layers, and unless you change some dependency, those layers are always going to be fetched from the previous image, so they are never going to be installed again. So you don't have to spend 5 minutes installing dependencies. We also help with build times by building our own wheels for Alpine images, because we use Alpine almost everywhere, so trying to install stuff like NumPy or Pandas in Alpine, it takes perfectly 15 minutes. And we provide many templates for CI, because we already figured out stuff that it's more optimal, and the only way to distribute it to everyone is to make them use a template. We have a Docker build template, which is using the best practices for it. It's going to be fast always. And you don't have to maintain it. You just import it in your pipeline and use it forever. We will keep it updated. We will update it with newer versions. Everything's going to be up to date. So we check that every CI file in our whole repository has always using our templates. GitLab config, which is just some small things like check that master branch is protected, which is on by default, but some people turn it off for some reason. That merge requests are blocked if there are unresolved discussions. That prevents people just forgetting that there was some discussion in place and approving and merging the code without actually finishing the discussion. And also block them if the pipeline has failed. This one, I think it's also on by default in GitLab, but it wasn't when we built it. Slack, we want to have Slack integration for every big project because it allows us to have a huge log of what happened on that repository and what's the history before everything. We have you without having you to go to that repository and checking every merge request. And also the code owner's file should be used for big projects because it allows us to have easy approval rules. Like for example, the one stated in the code owner as the owner for this part of the code should be the one approving it, which usually makes more sense because that guy is the one who wrote that part of the code, and he's probably the best one who understands it. And check Dockerfile. As I said, we use Alpine everywhere possible. It helps us with having smaller images and also important, more secure images. There was some article some time ago about comparing the base Node image with Alpine image, and it was like an older version of the Node image. And after, I think, only 1 year, the one based in Alpine only had like 30 vulnerabilities, which is also a lot, but the other one had like 800. So at the end, it's not only helping by being smaller, it's also all the stuff that you remove can have vulnerabilities that can be exploited somehow, and you get rid of those as well. Root users should never be used for running the Docker image. That's just good practice, and we just want to make sure that it's everywhere. Copy is used instead of add, and all the run instructions are merged, so we end up with less layers, like smaller layers, because at the end, if you are installing dependencies and then clearing up the cache into different layers, you have those deltas twice, because you add files and you remove them. If you do everything in the same layer, it's a smaller layer. It only caches the stuff that changed, actually, which is only going to be the essential files, not the cache files. Namespaces should be used because it helps us removing, like, just uninstalling the build dependencies. For example, we install different dependencies for build time and runtime, and at the end of the process, at the end of the layer, we just remove the build dependencies. And as I said, we built Python Alpines for Python wheels for Alpine to speed up our build times. We are having like a cron job, iterating over a list of packages and always trying to build the latest wheels for them. So we want people to use pip custom platform for getting those wheels from our own PyPI. The setup it's extremely simple. It just checks that all the packages are published under our own emails. We had some issues with people just using their personal account, and then like having this issue where in PyPI you cannot republish a package. You have to post upload a post package. So I don't know. It's just a way to ensure that we don't have those problems again. The package should be marked as private, because right now we are trying to open source as much as possible, but not everything is ready yet. And all the requirements are used. Sometimes we had issues with people adding too many requirements that weren't used. For the README file, basic check that there is a README file. Many projects don't have one. Even if we provide cookie cutter templates for all the projects, and people usually are using them right now, for some reason, if they don't have code yet, they just tend to remove it, and like you end up with a project that you don't know who actually should be maintainer of that project. The maintainer has to be specified, so in case you need to ask something, you can just go to the README file and check who is the one maintaining this repository. Same for discussion links, usually Slack channels, because we are using Slack for communication almost all the time. And documentation, which is almost every time just an appendix in the README file itself. And something that we also found quite interesting is to monitor like activity in the README file. We had projects with README file done when the project was created 4 years ago, and it was totally out of sync with the current state. So again, it's something quite easy, but once you have 1,500 repositories, you want to make sure that everyone is following these rules. It's easy to keep 30 projects, even like 50, but once we get at some scale, it's hard to make sure that everyone is following these rules. And that's it. Any questions?
You said that Zoo supports CI. Did I understand you correct that it not exactly supports? It it has integration of CI into it. It doesn't do CI. It takes CI results from something else like GitLab. CI.
It's a CI, like you can use it as a CI job. So one of the jobs on your CI pipeline, it's calling the zoo, and that will get you the report of what's the difference between our current auditing report and your code changes. Like if you in some merge request introduce some broken, like something that breaks one of our rules, you will get notified.
Okay, so how is it connected with GitLab CI then?
It's just an API call right now. We have a GraphQL API, you query it, and we have like a small script that queries that and prints the difference. I can show it to you afterwards if you want.
Oh, okay.
Maybe I'm not explaining it correctly.
Sure. So thank you.
Welcome.
Okay, thanks. More questions? Yeah.
Hello.
Hi.
Thank you for presentation.
Okay.
I have a question about the microservices.
Yeah.
How do you versioning this? And about end-to-end testing.
Mm-hmm.
Do you have it? If yes, what do you do when two microservices is updated? Thank you.
Yeah. So the versioning on each service depends a lot on the team that develops that service. Usually, almost everyone just follows the same convention of major, minor patch versions. For end-to-end tests, we do have them, and what we have is just a bunch of clusters that we deploy, like multiple versions of it. About what we do when there are different, like two services updating at the same time. We don't really check that because the way how we have microservices, they always have to be like compliant with the other ones. We have many teams that are working totally separated, so we don't rely on that communication of both updating something at the same time, which should break anything. Like there shouldn't be any breaking change. If there is a breaking change, it should be announced. And there should be like a time where the other team that is consuming that service can adapt to the changes.
Thank you.
Welcome.
Hello, and thank you for your talk. I have two questions.
Yeah.
First, does this only work with GitLab? So can we, for example, integrate it with a Bitbucket server?
It does work with more stuff than GitLab, but it doesn't work with Bitbucket. It's GitHub only, like GitHub and GitLab.
Okay, and second question, do you have some solution for automated creation of new repositories, new microservices, for example, some templates or
cookie cutter templates.
And when those templates update, how do you roll out these updates into your services?
We usually don't. Like once you use the template for generating your project, you don't use the template again for modernizing. And that at that point, if we find out something that we don't want to have that anymore, we usually just write a check for the zoo. So we have like a list of which repositories are still using the old version and how much time do they spend to fix it and when it's fixed.
So like, for example, if you want to switch from YEP to black or something like that, you just write a check and every team gets this in their report and just...
Yeah, and for something like that, we can even like send an automatic merge request.
Okay.
Like once we figure. Oh, okay. Oh, sorry. We figured out some issue we had with Unicorn. We have a Unicorn in front of some services, and that worked fine with our previous cluster setup. We migrated to a new cluster setup, which has like it's a huge node with 1,000 CPUs. And then, of course, the basic Unicorn configuration relies on the number of CPUs, so it was spanning like 1,001 processes for that, which is insane. And that change, actually, we have it automatically fixed from the zoo. Like we submitted the code differences to all the repositories, and they just reviewed it and approved, and it's merged, it's fixed.
Thank you.
Welcome.
Yep. Okay. Questions? Okay. How many time takes the zoo regularly to make its job inside the CI? How many percentage of the whole CI process it takes?
Usually it's like 5 seconds, something like that. It depends a lot on the size of the project and on the tools we use. As I mentioned, we use Bandit for security checks, and Bandit has some specific issues if the project uses, I think it was NumPy, because it tries to build an AES tree of the code, and there is some part of it that takes much more time. In that case, yeah, I think for that project specifically that I'm talking about is like 40 seconds in total. But if not, it's usually really fast because it's like just text search and parsing some YAML files or something like that.
Okay, and what will be if zoo fails, for example?
What do you mean it fails? So if the check itself fails?
Yeah, it takes some fails or
it's reported,
exceptions inside.
It's reported to Sentry for getting the error there. It's reported to Datadog as well for gathering like metrics of how many fails we have. And that's it. Like it won't be reported the issue because if it accepts inside, we cannot really know what happened there. So if it accepts, that issue is not reported because that issue we cannot prove that it exists. And we will get a warning in Sentry, so if it's our fault because it's broken, we will fix it.
Okay, thank you. That's all. Thank you very much. Right. And you need to choose the best question, not mine.
These questions were good.
Which one, sorry?
I don't know the name, so.